Students. In this session, let us discuss the last program of this AI lab, that is week 5, text processing using NLP. So we already discussed some of the theoretical concepts of this NLP, that is NLP pipeline, what we are going to do the processing, like converting a paragraph into sentence, then into words, then performing removal of stop words, then performing stemming and lemmatization, parts of speech tagging, like so many text processing techniques we discussed. Now let us discuss. Now let us execute one program using this text and using NLTK for this text processing. So to perform any of the NLP tasks, the very first important requirement is we need to install this NLTK, that is Natural Language Toolkit. For that, just simply you can write a piece of code like pip install NLTK. So once installing this NLTK, we are going to import some other packages, like we need to download this punctuation, stop words, wordnet. Why? Because for further processing of text processing, we need all these things. So from NLTK, installing NLTK, first you import NLTK, and from NLTK you download this punctuation, stop words, and the wordnet. Once downloading this, then we can perform all these things. The very first one is sentence tokenization. It simply breaks that paragraph it into sentence. So here I have taken the text, a piece of text as the input, this paragraph as the input, and I'm performing the sentence tokenize. For that, I'm going to import sentence underscore tokenize from nltk.tokenize. And that particular for text, I'm performing sentence tokenize and I'm storing it in tokenized word. I'm just printing the tokenized word. So here you can see this particular paragraph is going to be converted it into sentence. Wherever there is a, it is going to have a full stop, that it is going to taken it as a sentence. So once a paragraph is converted it into sentence, the next one is the sentence, that is sentence, we are going to convert it into words. That simply we call it as a word tokenization. That is that words we can also call it as the tokens. So for that, we need to import word underscore tokenize from nltk.tokenize. So I'm performing this word tokenize on the given text and print and storing it tokenized word. I'm printing that tokenized word. So here you can see each and every word, single word, comma, full stop, double quote, single quotes, everything will be taken it as a token. So in that way, it is going to break the total paragraph it into tokens. And here simply I'm running this piece of code, that is just to know the frequency distribution of the tokenized word. We have converted it into tokens. Just I want to print the frequency of the tokens. That is, we've got an output something like 66 samples and 111 outcomes. So this samples indicates the unique words in this particular sentence, and 111 outcomes is the total number of tokens in the given paragraph. And then I just want to print the most common two words. The frequency I'm asking. So here it has given like comma, it is repeating for 6 times, and two is repeating for 6 times. Okay. So now the next one important text processing technique is removing the stop words. We know that in a paragraph or in any text, we find like I, a, and, the, that, this, which don't have significance meaning. So those are all, we call it as the stop words. So we are going to remove the stop words. For that, we require this. We have to import the stop words from nltk.corpus. We are going to import the stop words, and stop words are the English stop words. So stop words are what? From English, this dictionary, it is going to download the stop words, and it is going to be converted it into a set for easy lookup table. It is going to convert it into a set, and it is going to print the stop. Then I'm just saying that print stop words. So these are the some of the stop words that we have downloaded from this English dictionary. Okay. Now, next, just as writing a piece of code, just means I want to print a tokenized sentence before stop words and the after stop words. So here we need to find out for each here here this created a simple token, that is initializes an empty list to store words that are not stop words. Okay. And we are iterating through each word in the tokenized word and checks if the word W is not in the set of stop words. And then it is going to add the words to the filtered sentence list and if it is not a stop word. So then we are going to print the statements like tokenized word and the filtered sentence. So when you see the output of this and this, here we have stop words like a, with, okay, it, okay. So with all this, some see here. So this tokenized sentence and filtered sentences, after removing the stop words, we are printing the filtered sentence. And the next one is stemming. So we know that there are two important in NLP. We discussed that stemming and lemmatization. So these are all nothing but it is going to be perform it into a root word. So we are going to perform the stemming and lemmatization. So when you observe the output of the stemming and lemmatization, we see here this rendigious, it is going to give, it is give a root word, but the thing is it is not going to give the dictionary meaning. So but when you perform this the same perform with lemmatization, it is going to give you the dictionary meaning. But here, when you see this output of this stemming and lemmatization, even here lemmatization also not giving the proper answers. Why? Because it is unable to identify a particular word, whether it is a noun or a verb. Suppose take a word like book. If a book is related to a library, then we can say that book is a noun. But it's the same thing if book is like I want to book a flight ticket, then in that case that book is a verb. So we have this NLTK has to understand that context of that particular word, it is a noun or the verb. For that sake, we have one more important text processing step called as the parts of speech tagging, that is POS tag. So once you give parts of speech tagging, then easily it is going to perform the lemmatization. So for that, we need to download OMW, that is Open Multilingual WordNet, and from that first we need to perform the stemming and lemmatization. And for that, I'm assigning these parts of speech. So POS is nothing but the parts of speech tagging. So here we are doing this lemmatization with multiple pause tags. So what here we are doing in the very first step, pause equal to n. That is first lemmatization lemmatizes as a noun and then refines further by treating the word as a verb. Here, that's why we have given it as verb. And final refinement, treating the word as an adjective. So if you perform in this way, then this NLTK will understand whether that particular token in the different context it will be acting as a verb or not. Okay, so once you perform this one, you can see here dispute. It has given you the correct root form. But whereas here you can see the output of dispute, it is not giving in the same way. See here it has given disputed. Root word it is not giving. So once you perform parts of speech tagging, then only it is going to give you the correct root word. So before you perform lemmatization or stemming, better it is very good practice to perform this parts of speech tagging. Okay. Next, a simple piece of code actually I have written here, that is NLTK.download average underscore perceptron tagger. So what it is just you want to know after once downloading this one, if you write like NLTK.pause underscore tag of each lemma word, means each lemma word, you want to know what it is parts of speech tag. So you can see here, this I'm printing the all lemma words and with its parts of speech. So I is PRP, Rendigious is VBP, death is NNP, something like that. We got the output. So what are all these? This NN, VB, JJ, what are all this? So you want to know this, what is this? So next, simply just you download these tag sets. Just from NLTK, you download tag sets and write a piece of code like NLTK.help.up ENN underscore tag set of JJ. That means whatever you found here, JJ, that I have written. So here it is going to give it as adjective. JJ is nothing but the adjective. So RB is nothing but the adverb. NN is nothing but the noun. So in this way, whatever the parts of speech tagging full form, if you want to know, just simply download these tag sets and just simply type this piece of code. Then you will come to know what it is. And here just I have written a piece of code, that number of nouns in this particular lemma words. Just it has given these are the different nouns in this particular sentence. So in this way, we are going to perform the text processing using NLTK. Thank you.